Facade is a structural design pattern that provides a simplified interface to a complex subsystem. In other words, it hides the complexity of the underlying components behind a higher level, easier to use API. As a consequence, clients don't need to understand the details of the subsystem to leverage its functionality. Instead, they access the subsystem through a single entry point provided by the facade, which in turn forwards the request to the appropriate components. The facade pattern can help simplify specific tasks while decoupling the consumer side from the underlying frameworks or types. It's also helpful to narrow down the functionality of a library so clients are exposed only to what is necessary for their tasks. The perfect candidates for the facade pattern are libraries, frameworks, or any subsystems that are still evolving and may require changes in the future. To protect our clients from these changes, we can design a facade that wraps the entire subsystem and provides a stable interface. Changes to the underlying subsystem won't affect clients as long as the public interface of the facade remains intact. The facade design pattern includes two main components: the facade class that exposes a simplified interface to the underlying subsystems, and the subsystem classes that provide the actual functionality. Here's a practical example to demonstrate the facade pattern better. Consider a smartphone. A smartphone has many parts, such as a processor, battery, memory, cameras, and more. As users, we don't need to understand how each part works. Instead, we can use a single interface, the touchscreen. The touchscreen is a good analogy for the facade. It provides a simple, unified interface to access the features of our smartphone. The facade design pattern is straightforward to implement, as you'll soon see. There are a couple of pitfalls, though. The most common design issue is that the facade may become too big and integrate too many features, breaking the single responsibility principle. To avoid this, design the facade with a specific purpose and ensure it is well scoped. Exposing the underlying types is another potential problem when implementing a facade. By doing so, clients may bypass the facade, rendering it useless. To prevent this, design the facade as an opaque black box and don't expose any underlying types. Now let's look at a demo project that will help us understand the need for the facade pattern. Let's say we are building a hotel reservation system. The system needs to coordinate the work of several existing components such as a database library, a payment gateway, and a messaging service. Here's the source code of our demo project. We can see that each component or subsystem is implemented as a separate class. We have a database class to store reservations, a payment gateway to process payments, and a messaging service class to notify customers about their reservations. To keep the demo straightforward, these classes do not implement the actual functionality. Instead, they just log a message to the console. When a customer books a reservation, the system needs to store the details in the database, process their payment with the payment gateway, and notify them with the messaging service as demonstrated in the main function. Thus, we have to instantiate each class and call their corresponding methods in a specific order. This requires us to add a lot of code to achieve the desired result. Our code is tightly coupled with these components, another design issue. Plus, we need to understand the interface of each class, as well as their interactions. Although this is a simplified example, it highlights the problems we can face when working with complex systems. Fortunately, we can simplify the use of these components by applying the facade design pattern. First, we'll create a facade class. Let's call it Reservation System Facade. This class will encapsulate the functionality of our existing component classes and provide a single, simplified interface for making reservations. So we'll need to add the members of each component class as private data members. First, the database. Let's call this data member mDatabase. We'll also need a payment gateway. And finally, a messaging service data member. Next, I'll create a constructor and initialize these data members. The constructor should be public. And I'll initialize these data members in the initializer list. mDatabase first, followed by mPayment gateway, and finally the messaging service data member. Next, I'll define a simplified interface, a method for making reservations. Let's call it make reservation. Now, what are its arguments? Let's revisit the old sequence of calls to see what needs to be done here. So first, we'll store the reservation info in the database. The second step is to process payment with the payment gateway. And the third step is to notify the customer with the messaging service. So I'll need to pass in the reservation and payment information as parameters. The message will be generated inside the make reservation method. And the second argument, also a string, is the payment info. And now I'll call the corresponding methods of my wrapped components to implement the desired functionality. First, I'll store the reservation using the database. Then I'll use my payment gateway data member to process the payment. And finally, send the confirmation message. How about reservation confirmed? And the final step is to use the reservation system facade class to simplify our code. Instead of directly interacting with the underlying classes, clients can now use the simplified interface provided by the reservation system facade class. So I'll go ahead and remove the old code and use the newly created facade class instead. Okay, let's fix this typo. It should be camel case. And finally the constructor. Okay. Let's call this instance reservation system. I'm going to borrow these strings from the old code and the payment info too. And now let's call the reservation system facade's instance make reservation method. I need to pass in the reservation info and the payment info. Perfect. With just a little extra effort, we've created a facade that will save us time each time we need to make a reservation. Clients don't need to interact with multiple classes and learn their methods and dependencies. Instead, they can make their reservations quickly and easily through a single interface and method call.